One popular feature in MOBAs and top-down games is unlocking the camera from the character in order to navigate freely through the map without carrying the character with you. That's exactly what we'll learn to replicate today in a very easy and customizable way, so you can change values really quick to adjust how it works. Before starting, if you want to understand something, let me know down below so I can help you out. As well, if you want to learn more about Unreal Engine 4, both its features and how to recreate mechanics, level design and game development in general, consider subscribing so you don't miss out on any of the upcoming videos. And now, without further ado, let's hop right in the tutorial. We are going to start this tutorial with the default top-down template Epic Games gives us with Unreal Engine 4. It is going to be the foundation for this feature and it is also going to work perfectly with it. Now let's open the top-down character and let's go in the viewport. In here, the first thing that we'll do is to go to the spring arm and create a new camera. And I'm going to call this unlocked camera. The camera that comes with the template is going to be called main camera, just so we can make the difference between them. Okay, now let's go in the event graph, and before writing any code, let's see the components of the feature we are creating. A simplified version would be moving the camera based on the mouse position, which means we'll have to check the position very often. For this, we could use event take, but that's really not good performance-wise. Therefore, we'll use a workaround, that being a set timer by function name. We'll hook this up to the event begin play, so let's get that real quick. I already have this in here, and with this piece of code, you do not have to delete it. It's essential to this template, and as I said, what we'll do is to get a set timer by function name. Okay, let's hook this up in here and this one in here, and as I said, we will need to check this very often, so the time is going to be 0.01 or even less, 0.001. Then let's check looping, and we're not yet going to input a function name. Next thing that we want to do is to get our unlocked camera and get a detach from component. Set the location rules, location, rotation and scale rules to be keep world for all of them. Now let me explain what this does. This is basically a node that is going to detach the unlocked camera from our character, and it is going to have nothing to do anymore with the position, translation, scale or whatever from our character. But we are still going to have it in our component, so we can still access it. Okay, now let's create a custom event. So add new custom event. Okay, and I'm going to call this camera movement. Okay, let's input this in the function name. Now let me explain why we are going to create a custom event and not a function name. There's not a big difference between the two. The only difference that I know with the custom events is that custom events allow the use of latent nodes, meanwhile functions do not, so you cannot use delays or timelines in your function. Okay, now before setting up the camera movement, let's see what else we have to do. We will need to see how we can switch between locked and unlocked. So in order to do that, we will need a new input. So let's go to project settings, input, action mappings, and let's create one real quick. I'm going to call this camera unlock toggle. And I'm going to bind it just like in League of Legends to Y. Okay, now back in our top-down character, we are going to search for the name of our input action, so camera unlock toggle, and we are going to have this here. So now every time we are going to press Y, this is going to be called. Now from pressed, what we want to do is to get a flip-flop. And what a flip-flop does is that it alternates between two pieces of code. So basically, the first time we are going to press this, the A pin is going to fire. The next time we are going to do that, the B pin will fire and then it is going to get reset. Which means that the third time it is going to be A, fourth time B, and then it is going to reset once again. Okay, from A what we want to do is to set a variable, but we don't have one yet. So let's create a new boolean. I'm going to call this camera lock. And by default they should be true, because by default we are going to lock our camera to the player. Let's set this to be true, to be false actually, because if it's by default true, the first time that we press it we want to set it to be false, and then the second time we want to reset it back to true. Okay, now from the false set, what we will need to do is to get our main camera and get a set active node. And then the new active should be false, so unchecked, which means that we are going to deactivate our camera, but we will need to have another camera active. And for that we have our unlocked camera. Let's copy the set active, paste it in the target, plug the unlocked camera and set new active to be true. So instead of having our main camera active and it being the viewport, we are going to have our unlocked camera to be the viewport. Okay, now we can copy these and paste them, and we should just reverse the values. So for the main camera, the new active is going to be true, and for the unlocked camera, this is going to be false. And what we can do here is to set to have a print string just to check if it's working or not. This one is going to be unlocked. Okay, and the other one is going to be simply locked. Okay, let's compile. And in order to see the difference better, I'm going to drag the unlocked camera a little bit further away from the character. Right, compile. And now let's see. I'm going to move in my scene a little bit, and then I'm going to press Y. And as you can see, now I'm going to be further away, and my camera is also not going to be attached to the player, which means that it is not going to follow him. As well, in the top left corner you can see the print strings, locked and unlocked. That means that everything is working. Now the only thing left that we have to do is to set the camera movement. First thing that we want to do is to check whether camera lock is true or not. We are going to get camera lock, but we are not going to simply plug this in condition. First, we are going to get a not boolean, which is going to reverse the value of camera lock. So for instance, if this is true, the not boolean is going to make it false. That meaning that the branch will return false. Okay, so if this is false, we are going to do set the world location of our unlocked camera. So set world location. Okay, and then the new location is going to be the world location of our main camera. So get world location. Okay, now let me explain why we want to do this. So the first thing that you probably noticed is that we used false and not true. And let's see why. If our camera lock is true, that means that we are using our main camera, right? As you can see, camera lock, our main camera is active. That means that with a not boolean, true is going to be transformed into false, which means that we are going to run this code on our unlocked camera, so the player won't be able to see that it happens. Now let me unplug this from here. Okay, let's move, and then let me press Y. As you can see, the camera is going to get somewhere teleported, and it's basically going to be the start of our character, right, where it got spawned. But we want to somehow follow him after we press Y once again, right? So by hooking it in here and also going in the viewport to reset the location, if I'm going to play and now I'm going to move around and press Y, you can see that my camera didn't get teleported again. But right now it is still the unlocked camera active. If I'm going to move my character, you're going to see that I'm not going to follow him. If I'm going to press Y once again, I'm going to get back at him. And then if I'm going to press Y once again to set the unlocked camera to be active, I'm still not going to teleport back behind where I was, which is exactly what we want, right? We don't want to get teleported back to a previous location that we don't even know about anymore. Okay, and now what we have to do is to see how we check the mouse position and also how we want to move the camera. And now to check the mouse position, we are going to work with the true from the branch. The first thing that we'll have is a sequence. Why we are using a sequence here is because we are going to check for both X and Y on our display, on our screen. Okay, and before setting up anything, let's create a function, and I'm going to call this mouse check position, compile, and this is going to serve as a pretty dynamic way of checking on both axes. I'm going to have here an input, and it is going to be a boolean, and I'm going to call this x/y, which means that if this is false, the value is going to be for the x-axis, and then if this is true, it is going to be for the y-axis. Okay, the first thing that we need to do is to get player controller, and then get the mouse position. Now we are going to have these two values, and we want to see if we want to get x or y. So we are going to need to have here a select node, and what a select node does is it selects between two values, one of them based on an index. Our index is going to be the boolean from the input, and as I said, if this is going to be false, we will need to get the x value, and then if this is true, we will want to get the y value. Okay, then we will need to check the return value that we are getting here. We want to check if this is lower or equal to something, or if this is bigger or equal to something else. But first we need to determine what value we want to input in both of these. So for that we are going to get viewport size, and let's split this vector 2D into x and y. Once again we are going to have a select, which is basically going to work the same as this one from the get mouse position. The index, once again, the x and y input, and then what we need to do is to get here a float divided by a float, and then float minus float, and from the return value another float divided by a float, and this one is going to be plugged in the subtraction. Okay, now let's put in here from the one 9.6 and then 9.6, and don't worry, I'm going to explain everything after I finish setting it up, so I can explain everything what it does. Okay, now we are going to input this one, the subtraction, in the second one, and then the first one in here. Okay, let's compile, and then we will need to have a return value, so I'd return node, and we are going to have two booleans. Okay, return 1 and return 2. The first one is going to be plugged in return 1 and the second one in return 2nd. Let's compile it now. Let me explain what everything does in here. So the get mouse position is self-explanatory. It gets the location on X and on Y based on the viewport size. So for example, if our viewport would be, let's say this here is 19 by 1080, right here in this corner this would be 0, 0, right here this would be 1920 by 1080, and in the middle it would be the resolution divided by 2. Let's get back in here, and again the select is to see which axis we want to check. Okay, then we want to see if the mouse position, let's say for instance X, right, is lower or equal to something, and then if this is bigger or equal to something. And that something is going to be the viewport size, and we will want to get the according value to the axis that we are going to check. So we don't want to get the return value Y while we are going to check for the location X. We want to get X with X and Y with Y. Okay, then we're going to divide the return value, so in our case the viewport size on the x-axis, by 9.6. This is a value that I found was pretty good. If I'm not mistaken, 1920 divided by 9.6 is somewhere about 200. So that would mean that we would get about 200 units from left to right. Okay, and then here from our subtraction we are going to get about 200 units from right to left. So this is going to work as an offset to our viewport. So whenever we are going to cross these margins, right, these borders, we will know that we are going to have return 1 and return 2. One of them is going to be true and one is going to be false, or none of them is going to be true. So if I'm going to, let's say, get here these two cubes and place them in a way so it fits the current setup. Let's take for example that about this much is 200 units from left to right, and about this much is 200 units from right to left. If my mouse is going to be anywhere here, my return 1 is going to be true. If my mouse is going to be anywhere here, return 2 is going to be true. And if my mouse is going to be somewhere in the middle, none of them is going to be true. And the same thing goes for the y-axis. We are going to have about 200 units from top to bottom, and then 200 units from bottom to top. And if my mouse is going to be anywhere here or here, one of the values is going to be true, and if it is going to be here in the middle, none is going to be true. Right? So this is how we can check if our mouse is going to cross some borders. Okay, and now let's get our function, plug this in here, because from then 0 I want the x-axis, I'm not going to set this to be true, but on the then 1 I'm going to set it to be true because I want the y-axis. And now we are going to go on and see how we can move our unlocked camera based on these values. Now that we know that we have some return values and we know the mouse position, let's get here some branches, and we just need to plug in them just like this. So return 1, a branch, and then from false, a branch with return 2. Right, let's copy this, copy, paste, and do the same thing. Okay, now let's create a function. I'm going to call this move camera, and this function will actually going to move the camera. So this is the most important part. Let's get the new input. The first one is going to be called direction, and then in parentheses forward/right. So that means that for false, direction is going to be forward, and for true, it is going to be right. Okay, and then axis in parentheses plus/minus and close parentheses. So once again, for false, the axis is going to be positive, and for true, the axis is going to be negative. Okay, now let's get here some selects. So we are going to get 2 for now. One is going to have the index direction, and one is going to have the index axis. Now let's get here make literal float, which is just going to have a float value, so it's nothing too special. We can just plug this in here, and then plug this in here, and delete them. Actually, no, we can't. So perhaps we can just give here a small value, and then unplug this and delete it, so we can just set them directly in select. Okay, for false, we are going to have this 100, and for true, we are going to have this 0. Now let me explain. For false, that means that our axis, our direction is going to be forward, right? If this would be true, that means that we want to move to the left or to the right. But no, we want to move forward 100 units. Right? And then here for the other select, false should be 1 and true is going to be -1. Once again, because on the positive axis, if this is false, the false is going to be positive, and if this is true, it's going to be negative, just for the minus. Okay, now what we need to do is to multiply these values, so float multiplied by float. So this way we can change the direction, not the direction, the axis that our direction is going to be impacted by. Okay, and then let's get our unlocked camera. Let's get world location and split the return value so we get all the 3 axes. Now what we'll do is to add here for the x1, we are going to add the multiplication here, and let me show you why we want for the x-axis. If you're going to go in the viewport, you're going to see that our camera right here, its x-axis is right in front, right? It doesn't matter that it has here an angle, right? With the z-axis, the x-axis is in front, and that's what matters. Okay, now let's copy this one more time. So from move camera, let's copy this, but this time we will need to reverse the values. So for example, here to false, it's going to be 0, and for true, this is going to be 100. We do not need to reverse these ones for the axis, just for direction. So if direction is going to be false, we are going to have here 0, and if this is true, we are going to have this true and 100. As well, we want to multiply these, and then what we want to do is to get the y-axis and once again have an add. So let me try to explain this for you and what it does exactly. So if we are going to have our mouse here at the top, we will want to move forward 100 units, and that's why we want to add to our x-axis 100. But if it is going to be down here at the bottom, we want to move 100 axis on the negative value, which means -100, which means that here we are going to subtract 100 from the current location. The same thing goes for the left and right. if our mouse is going to be to the right, this is going to be positive, but if it's going to be to the left, this is going to be negative. Okay, now what we have to do from here is to get a make vector, and the only axes that we need to put in here are the y and the x, right? We don't have to mess up with the z. Then we will need to get a vector interpolation too, and then let's see what we want to set with this. The first thing that we need to do is to get a world location from our unlocked camera. Okay, make sure that these are still split, and then make vector and just replug them once again. The reason we are doing this is because we are going to use the z-axis later, so we don't have to get it once again and then split. Plug this in current, then the target is going to be our return value. The delta time is going to be get world delta seconds, and the interpolation speed can be whatever you want. It can be 1, it can be 2, and it can even be a value, a variable. So for example, I'm going to call this speed. It's going to be a float, compile it, set the value by default 1, and then just plug this in the interpolation speed. Okay, now what we'll need to do is to get from the execution pin set world location. Let's see. The world location doesn't matter what you get, you can change it now. So this is a spring arm, and we're going to get unlocked camera. This is going to be our target, and now let's split the new location. We are going to also split this, and we are only going to plug in x and y. The z is going to be the one that we kept in here for our get world location, so the z is always going to be the same. It will never change, and it will be just right here at the top, because we do not want to change it, let's see, like this. We only want it in front and to the left, or right, of course. Now let me try and go over this once again and explain it maybe in a better way now that we have it all completed. So what we're going to do is to check if we want to move forward, right, using the direction. And if you want to move forward, we want to see if you want to move forward like this or backwards in the opposite way by using the axis. And we are going to change the axis by just doing a simple multiply with -1, and then we are going to add this to the x value from our get world location from the unlocked camera, which means that we are going to change the world location. And then we are going to do the same thing for the y, that means left and right, 100 once again, and the axis is the same. And then we are going to make a vector, and we are going to interpolate between the current location and the location that we want, that we chose for our mouse. And then the z is always going to be constant, so that will never change. Let's play and let's see if this is working or not. I'm going to press y, and now it's unlocked, and now I'm going to move my mouse. So it currently seems that it's not working, and that is because we never did anything in our event graph. We need to add this. So what I'll do here is to get move camera. Okay, move this a little bit above, then from true once again. Okay, just like this. And the last thing that we have to do is to set these booleans accordingly. And now let's see why we want to set them in what order. So for our mouse check position for the X, that is going to be to the left and to the right, which means that we need to check this. And also, this is going to be false. Okay, then for the direction here as well, check this. And then of course, if this is checked here, we will have this unchecked. Then here, because both of these are checked, we are not going to check any of these. And the only thing that we have to do here is to check the last one for the axis. Now let's see if this is working or not. It should be. And as you can see, it's working perfectly. You can even snap back to it and just walk wherever you want. The only problem with this right now is that if my mouse is not going to be on the viewport, it's going to go crazy. So I expect you working in a game with full resolution, right, on full screen, so there's no way for the player to have his mouse not somewhere in the viewport. because if you're going to have that, you are going to get this error. And perhaps you could set here a check and see if the mouse is on the viewport or not. And that concludes today's video. I hope that you found this tutorial helpful and informative, and if you haven't understood something, let me know down below so I can help you out. As well, if you want to learn more about Unreal Engine 4, both its features and how to recreate mechanics, level design and game development in general, consider subscribing so you don't miss out on any of the upcoming videos. If you should support me and get access to most of the project files from tutorials, just like this one, you can do that over on Patreon for as little as $1. That being said, thanks for watching and I'll catch you next time.